Hey, students, today we're looking at limits. Now, the way we read this, we want the limit as t approaches 3 for this particular function. For the function t minus 7, all we do is just substitute t equals 3 in it. So these limits will occur, this first function won't. Often we use limits if we've got functions like exponentials and things like that. So I'll just give you an example. So let's say I have this function here, and I might say, what's the limit as, I don't know, x approaches a certain value. See how the curve approaches the value but never reaches the value? That's when we use limits. What is this function approaching? I might say here, as t approaches positive infinity, what does y approach? As t gets really big, what does y approach? 0. And these are the sorts of things we're doing. But in these first few examples, I'm not doing as t approaches infinity. I'm doing as x approaches certain values. But what I'm doing is as x approaches certain values that we don't want it to be. So as x approaches 0. Do you see why we can't substitute x equals 0? This one, as c approaches 2. If c is 2, my denominator's 0. So the function does not exist for the value of, say, x is 0 or c is 2. Okay, but we'll know what that curve is approaching, what value of y that curve is approaching. All right, this is what this does. All right, so let's look at the first one. This obviously doesn't have a discontinuity in it, whereas these others do. X can't equal 0, c can't equal 2, do you get it? But this one, I just thought I'd throw this one in so that you can just see, as t approaches 3, we just substitute t is 3. What do you get? 3. The function approaches 3 minus 7, which is negative 4. Now this second one, the limit as x approaches 0 of this function, can I substitute x is 0? So no, I can't. So what we often need to do is factorize with this type. So I'm going to factorize out the numerator. So I've got x bracket, x plus 3 over x. Are we okay with that? What will happen with the x's? They cancel. And now I can substitute, sorry ladies, I should be writing limit, that equals the limit as x approaches 0 of that. So I've got equals the limit as x approaches 0 of x bracket x plus 3 over x, cancel out the x's. So now this is the limit as x approaches 0 of the function x plus 3. Now I can substitute. Can I substitute without any problems? Yes, so what do I get? 0 plus 3 is 3. Now, if I was to sketch this function for you, y equals x squared plus 3x over x, oops, sorry, equals x squared plus 3x over 3, and you know how we factorized out the numerator, we cancel the x's, we end up with the function y equals x plus 3. However, there is a discontinuity at 3, at x is 3. Sorry, there's a discontinuity, at x is 0. However, this graph is not showing that. You know, because when I look at this function, what values of x can you not have? 0. But we know that unless I zoom it and there's a little circle, but we know we can't substitute x is 0. But can you see when x is 0, y will approach, the value is 3 on that function. But we know that we're not allowed to substitute x equals 0 because x is on the denominator. So this is the value that the function approaches at x is 0. So if you looked at that graph that I had, as x is approaching, so the graph looks like this. Y equals, it looks like this. Now, if you approach x is 0 from below, isn't the y value approaching 3? And if you approach x is 0 from above, the value is approaching y is 3, but there is an open circle. That's meant to be an open circle. I'll draw it down here again. So this is what I've got, an open circle. This is actually the graph. This is the graph. X can't equal 0. If I factorize out the function, this is actually the line y equals x plus 3 with a discontinuity, with a circle, open circle at x is 0. Does it make sense? And at that open circle, the y value approaches 3. So we put an open circle around y is 3. So that is actually the graph of that function. It's different to the normal graph of y equals x plus 3 because that's just a straight line with no open circle in it. Are we okay? Let's look at the next one. Limit as c approaches 2 of c minus 2 over c squared minus 4. So that is the limit as c approaches 2. What should I do? C minus 2 over c minus 2, c plus 2. What cancels out? The c minus 2's. So I'm just going to go in columns. Equals the limit as c approaches 2 over 1 over c plus 2. Are we okay with this? Are we okay? So I have to write equals limit as c approaches 2 until I substitute. So I've written that. I've written the same thing, factorized. I've cancelled out. So that equals the limit as c approaches 2 of 1 over c plus 2, which is, substitute in the 2, and what do you get? A quarter. So if I was to sketch this function, it's actually, to sketch it, you go to the simplified version. Tell me what this function is. It's a hyperbola. Shifted 2 units to the, well, it's to the negative 2, yes. It's here. It's looks like this, but there is a discontinuity where? There's a discontinuity, sorry, at 2. At 2, so here I put an open hole at 2. Do you get that? And what would that value of y be if that value of 2 existed? This is not a half, by the way. So that's the axis. This would be the value to a quarter. Do you get it? Because that's the limit. The function is approaching that y value. So as c approaches 2, this function approaches a quarter. In other words, this is the point to a quarter, but it's got an open circle. Because you're not allowed to substitute 2. Does that make sense? Okay, the next one. So this is the limit as x approaches c. Do you remember how to factorize out the numerator? X minus c bracket x squared plus xc plus c squared over x minus c. The x minus c's cancel. I don't have to rewrite it all out. I can now. What do I substitute? Just look back at the others. This one's a little bit confusing. You know, as c approaches 2, I substituted c. Wherever there was a c, I put a 2. So what do I do here? Wherever there is an x, I put a c. So it's the limit as x approaches c of x squared plus xc plus c squared. So everywhere I see an x, I substitute a c. What do I get? C squared plus, c times c is, c squared plus c squared is. Do you get it? So if you look back at these, I got up to here. My last step was to substitute the c for 2. This step is to substitute the x for a c. Do you get it? This is c squared plus c times c is c squared. Plus c squared is what? 3c squared. Two types of limit questions. Limit as x or whatever c approaches some number or some value. Okay. At question 1D, while we're here, what is the domain and range, therefore, of this function? So what's the domain? Once I've sketched it. What have you got? Look at the function. What can't x equal? Look at this. What can't, yeah, x can't equal 0. So all real x can't equal 0, and the range, what y values? Looks like you can get everything. It is the function of y equals x plus 3, but there's a hole in it. What value of y can you not get?
3.
Yeah, it's all real y, comma, y can't equal 3. Let's look at this one, domain and range. Question 1I, that function there. What have we got? Domain. Well, look at the original function. Yeah, all real x can't equal -2, and the range, all real y can't equal a couple of things. Well, just look at the actual graph for a start. What can y?
0.
Yes, it can't equal 0. You'll never get, one sec. Because we can't have ever c equals 2, you can't substitute c is 2, so you'll never get 0 divided by something. So it'll never equal 0, because we can see from the drawing, but y can't equal something else as well. What else can, so I know this is the function we sketched, but this was the original function. There is a big hole in this function. Where is it? At which y value? This is the limit as c approaches 2 of this function. You get a quarter. Y can't equal a quarter either. So y can't equal 0 or a quarter. We are going to get on to some of these other types in a minute, but just looking here at exercise 510, determine which of these functions are discontinuous. The 2a, what sort of function is that? A? What is it? X squared. Concave up parabola shifted down 3 units. Are there discontinuities in it? No, there aren't. So that is not discontinuous. The first function is not discontinuous. There's no gap in it, okay? There's no asymptotes. What about 2b? What value of x are you not allowed? Yeah, so this is discontinuous. And the value of x for which it's discontinuous is x is -1. So what is a continuous function? Continuity. Many functions are continuous. That is, they have a smooth, unbroken curve or line. However, there are some discontinuous functions that have gaps in their graphs. An example is a hyperbola. Another type of curve, some curves can be discontinuous at a certain point, like the examples we just did with holes in the curve at certain values. For example, we did something like this before, okay? We can see that this curve here is discontinuous at x is 1. Can you see that? It's got a hole there. But we did a question like this. If you simplify it, it is the graph y equals x plus 1, but with a hole, with a discontinuity at x is 1. This function as well, you can factorize out the numerator and the denominator. When you factorize them out, when you factorize numerator, cancel, you'll end up with y equals x minus 1. And when you substitute in the value of -2, you get -3. But we know that x can't equal -2. So we know that this is the function of a straight line, x minus 1, with a hole at -2. Okay, so the function is y equals x minus 1 with a hole, with a discontinuity at x is -2. They're like the ones that we did earlier. Okay, the hole there. So, for example, the domain would be all real x, x can't equal -2. The range is all real y, y can't equal -3. Okay? That's those types of discontinuities and limits. If you look at 2c, x minus 1 has to be greater than or equal to 0. In other words, x has to be greater than or equal to 1. There's no hole in the curve. There's no asymptote. So you're looking for holes in the curve and asymptotes. Any values, any particular value of x not allowed, not half of the x values. I'm not worried about that. So 2c, this question here, is not, it doesn't have a hole in it or an asymptote. It just has certain values of x that are allowed. And x has to be greater than or equal to 1. What about d? What values of x can you not have? +2 and, no, just, no. No. X squared can never be -4. I think you're allowed everything. X squared will never be -4, will it? Because you square something, you'll never get a negative. So D has no restrictions, but what about E? What is the denominator? Look, with 2D, x squared plus 4 can't equal 0, right? That means x squared can't equal -4, but x squared can never equal -4 anyway. When you square something, you can't get a negative. So 2D has no restrictions. All values are allowed, I think.
So it's continuous.
Yeah, it's continuous. Yeah, we're learning how to draw that soon, okay? What about 2E? So x squared minus 4 can't equal 0. X is plus or minus 2, positive or -2. Okay, and you should be able to do these just by factorizing out, okay?